relate those using slope. Can someone remind me from last week what our formula for slope was? Yeah?
Y2 minus Y1.
Okay.
X2 minus X1.
Perfect. That is your slope formula. So what I want you to do is go through and label all of your points and find the slope of all three of these problems, okay? So find the slope between those 2 points. I'll give you just a few minutes to do that.
Am I supposed to skip some pages?
Yeah, you're on page 5, Hunter. Page 5. Yeah, again, just those first 2 pages, if you already filled them out in your other packet, just rip them off and throw them away. You don't need them. And I wouldn't keep them or else you might get confused. So just rip them off and dump them.
Or could I keep them and throw away the other packet?
Probably don't do that.
Can I write those?
No.
You can label them if you want. It might help you. I would say if you struggle with these types of problems, labeling them is super important. Logan, you should be doing some math right now. Is it your head or your nothing? Never mind. Try some math, bud. All right, let's do these together. For this first one, what is y2? Help me out. 2, what's y1?
3.
3. So 2 minus 3 on top. X2 is 5 and X1 is 9. So we have this fraction that we now just have to simplify. 2 minus 3?
1.
Negative 1. 5 minus 9?
Negative 4.
Negative 4. If I simplify this down, what do I get? Positive, yeah, 1/4. Those negatives cancel. So that means we go, if we were graphing this, from 9, 3, we could go up 1 and to the right 4, and we would get another point on our line. Next one, number 2. What's y2? 6. What's y1? 7. Surprised, are we not happy about this? When I filled this out last night, I thought we were going to go crazy. Do we need to try again? What's y2?
6.
What's y1?
7.
You guys always go, it's not cool if I do it.
6, 7.
Thank you. Oh my goodness. Thank you. Goodness. And then x2 minus x1, negative 1 minus negative 3. For minusing a negative, we are extra careful because this is going to turn into what sign? A positive. So negative 1 plus 3 gets me 2. And then 6 minus 7 is negative 1. And then our very last one, y2 is negative 2. y1 is negative 2. So we get negative 2 minus negative 2. X2 is negative 5. And X1 is 8. What does the top become? What's negative 2 minus negative 2? Say it louder. 0. This would be 0 over negative 13. So if I simplify that, what do I get? Not negative 13.
13.
Not 13. 0 divided by anything is just 0. Yeah, does anyone know what kind of line this would be that has a 0 slope?
No line.
It would be a line. Do you guys remember Hoy-Vux from Algebra 1?
Yes.
Is this Hoy or Vux? Do we know?
Vux.
Hoy, because the 0, the O, Hoy. So is this going to be a vertical line or a horizontal line?
Vertical.
Hoy with an H. Hoy, horizontal. Very good. Okay. Just a quick refresher from Algebra 1. So, again, we talk about slope because this whole chapter is over parallel and perpendicular lines, and they have some properties with their slope that we can kind of look at and figure out. But today, we're actually going to talk about a bunch of different angles formed by parallel lines. We're going to talk about that poster today. That will be your best friend for the next week, okay? So, what I want you to do for this first part, I want you to identify with your colors all the pairs of vertical angles. Does anyone remember what a vertical angle is from Unit 1? What if I went like this? Now, do we know what a vertical angle is? If we remember, it is the two angles kind of across from each other in that X shape. So here's one and here's another one. Those yellow angles are vertical angles. So if I look at, for example, angle 1 over here, what's angle 1's vertical angle? 3. Okay, so I want you to do that for all the pairs that you see. Try to list them out. Then, well, let's just do that part first. On your own or with the people around you, list all the pairs of vertical angles that you can find. There should be 4. You should have angle 1 and angle 2. And 5 and 6 should find a pair as well. So look at angle 1, angle 2, angle 5, and angle 6. And try to find which angles are vertical angles. We already said angle 1 was angle 3. What's angle 2's pair? I know it's Monday, but we got to wake up a little bit. What's angle 2's vertical angle? 4. What's angle 5's vertical angle? 7. And what's angle 6's vertical angle? 8. Perfect. So we have vertical angles in here. That's our X shape. And we also have linear pairs. If you remember, linear pairs were two angles that were adjacent, right next to each other, but on a straight line. And if we remember something about linear pairs, are linear pairs supplementary or complementary? If they form a straight line that measures 180 degrees, they would be supplementary. So again, these are two kind of things that are going to stay in this chapter as well. We need to know what linear pairs are, that's these two angles, and that they're supplementary. We need to know what vertical angles are, and if we remember, vertical angles are congruent. That's going to be a big thing today, is vertical angles being congruent. So let's look at angle 1. What other angle forms a linear pair with angle 1? What's right next to it and on a straight line? 2, if I cover it up like this. What's another one? What if I cover it up like this? 4. So angle 2 and angle 4 are both the linear pair for angle 1. So that kind of handles these 3. Let's look at angle 3. 2 and 4 again. Yeah, 3 and 2 make a straight line. And 3 and 4 make a straight line. So those two are linear pairs. Angle 3 and angle 2, and angle 3 and angle 4. And that handles these 4. So now let's hop over to the other piece. Let's look at angle 5. What two angles make a linear pair with angle 5?
6, 8.
Yeah, 6 and 8. If you look, we can kind of cover up 8 and 7, and we see 5 and 6 work, and 5 and 8. And then the last one, angle 7. What two angles make a linear pair with angle 7?
6 and 8.
6, if we cover it up like this, and 8, if we go like this, okay? So 6 and 8. We have to still know what those angles are, because the things that we're doing today, every diagram you see is going to look like this. You'll have two parallel lines, and you'll have something called a transversal kind of cutting through them. So get used to this picture with two parallel lines and a line through them, because that is what the rest of the chapter is going to be about, pictures like that. So we have linear pairs and vertical angles, but we also have 5 different angle relationships that we're going to talk about today. Before we get into those, we have to define a transversal. So the first vocab term for this section is transversal. A transversal is a line that intersects two or more coplanar lines. So it's hitting 2 lines that are on the same plane. And it's hitting those 2 lines at different points. I'll kind of talk about what that means in a second. But your general picture for a transversal is just 2 lines. And then we have a transversal going through. So this yellow line T is what we would call our transversal. What it means for the lines for it to intersect the coplanar lines at different points, what that's saying is you can't have something like this as your 2 lines and then count this as your transversal, because then they would all be intersecting at the same point. So this does not work for a transversal. Those 2 lines it has to intersect the 2 lines at different points. They can't all intersect at the same point. Okay, so get used to this picture. Basically 2 lines and a line going through them. And when this happens, all of these angles, all 8 of them, have these special properties. And we can kind of name pairs of angles. And when we name pairs of angles, there are 4 key words that we use to name them. First one is interior. This is where I want you to get your colors out. Pull out a color. I want you to highlight the word interior in that color. I'm choosing pink. All of your interior angles are the ones between your 2 pairs of lines. So I'm looking here, and I'm looking at angles between my 2 lines. What's up, JJ?
What color was the one that you highlighted?
This I did in orange. This I did in pink.
Oh,
If they look the same. Huh?
I accidentally highlighted.
That's fine. Just pull out a different color. No worries. But your interior angles are going to be these 4. 1, 2, 3, 4. Inside the 2 lines.
Should I do those dots?
Yeah, either like color the little angle in, put a dot in there, put like just a little color. But your interior angles are the ones inside, in between the 2 lines. Exterior is outside. So these 4. 1, 2, 3, 4. So what we do is we define these angles by whether or not they're inside or outside the 2 lines. And when we're looking at 2 angles, if they are on the same side of the transversal or on opposite side. So pull out a different color. For alternate, they're on the opposite side. So you may have one angle over here. I'm using a different color. One angle over here and one angle over here. They're on the opposite side of your transversal. I'm not really labeling angles here. I'm just kind of labeling general locations. So that's alternate. And then your very last one, consecutive. Instead of being on the same or on opposite sides of the transversal, consecutive angles are on the same side. So if you have 2 angles on the left-hand side, they would be consecutive. If you know those 4 words and what they mean, you know the 4 angle relationships that I'm about to give you. Okay, so these 4 all describe locations of 2 angles in a setup like this with 2 lines and a transversal. And tomorrow, or Wednesday, we're going to talk about special properties these angle relationships have. But for now, we're just identifying them. So your first one, alternate interior. What's that? Yeah. Alternate meant opposite sides, and interior meant inside. So we are looking for two angles that are in between these two lines, but on opposite sides of my transversal. So I'm going to pick one of my interior angles first. Here's one. This is interior. And its pair, to make it an alternate interior angle pair, would have to also be inside the two lines, but on the other side of my transversal, so down here. So alternate interior angles are those two purple ones marked. We would say those are alternate interior angles. Or another pair could be that green pair. Alternate, they're on opposite sides. Interior, they're in between. So the purple pair is a pair of alternate interior angles, and the green pair is a pair of alternate interior angles. Questions on that one? And again, these 5 things are just things that you'll have to memorize. I'm sorry. Next one is alternate exterior. So still opposite sides of the transversal because of the alternate, but exterior, so on the outside. So if we look at the outside 2 angles right here, on opposite sides of my transversal, but outside the 2 lines. Or these 2 right here. Again, outside, but alternating across the transversal. Yeah, it doesn't matter. You can change it if you want. But like the green should go together. These 2 should be in the same color because they're a pair. So the only difference between these 2 is the interior versus exterior. Next one has 2 different names, and you get to pick which one you use. Consecutive or same side interior angles. So you could say consecutive interior or same side interior. I'm going to use consecutive because that's just what I'm used to, but I might throw in a same side every now and then. So these are angles that are still between the 2 lines because of interior. But consecutive means they're on the same side of the transversal. So here's an interior angle. And here's another interior angle on the same side of the transversal and also inside. So those purple ones are a pair. Same thing for the other pair on the left side of the transversal. So consecutive interior means in between the 2 lines and on the same side of the transversal. And then our kind of last one with this same naming pattern is consecutive exterior. So consecutive means same side. Exterior means outside the 2 lines. So I need an angle outside the 2 lines. And I need its friend on the same side, but outside the other pair. So right down here. And the same thing for the left side. So again, the purple is a consecutive exterior angle pair. Our very last one, and this one's the hardest to kind of see if you're just looking at a picture. This one's corresponding. This one uses a different naming pattern. It's not kind of named with the alternate and with the interior and exterior. But corresponding angles are angles that essentially occupy the same relative position in two different groups. Meaning, if I labeled these positions 1, 2, 3, 4 on top, and I kind of name the same positions on bottom, meaning 1 is in the top left. So if I look at the bottom 4 angles, I'm going to put a 1 in the top left. 2 is in the top right, so I put a 2 there. 3 is in the bottom left, and 4 is in the bottom right. Corresponding angles occupy the same position, meaning angle 1 and this angle 1 are corresponding angles. So these two pieces right here, they're both in the top left. Same thing with the top right, those two angles. They're in the same position, top right. Bottom left, same position, so those two blue angles. And bottom right, that same position, so those two angles. So your pair of corresponding angles are essentially in the same spot for your top and bottom line. Questions on any of those definitions? I know it's a lot, and we're going to talk about them for the next 3 days. Okay, so now we're going to use this picture right here to identify all pairs of corresponding angles. First, I'm going to highlight my transversal just so I know, what's inside, what's outside, and what's on the left or the right of it. So there's my transversal. Now let's look at corresponding angles. What two angles are in the top left position? What?
1 and 5.
1 and 5. They're in the top left. So since they're in that same relative position, they're corresponding angles. Angle 2 is in the top right. What other angle's in the top right?
7.
Top right.
6.
6. Top and then right. So 6. Angle 3 is in the bottom right. What other angle is in the bottom right? Yeah, the bottom right down here is angle 7. And then the very last one, angle 4 is in the bottom left. What other angle is in the bottom left? Angle 8. So those are your corresponding angles. They're in the same spot, the same position. Think top right, top left, and the other two. Okay, next one is alternate interior. I'm going to kind of look at the interior part first. And I'm just going to pick an angle on the inside. Here's one. Here's angle 4. What angle is also on the inside, interior, but on the opposite side of the transversal? 6. Angle 6. So angle 4 and angle 6 are alternate interior. My other interior angle is angle 3. I need another interior angle on the opposite side as angle 3. What angle do we think that is?
5.
Yeah, 5. Not 8 because 8's on the outside, so it has to be 5 because it's on the inside. So angle 5. Alternate interior. Next one is alternate exterior. So again, I'm going to kind of use the exterior part first. I'm going to pick an exterior angle.
1.
Let's look at angle 1. What other angle is outside and on the opposite side of the transversal and with like the other line?
7.
Angle 7. Boom. Angle 1 and angle 7. My other exterior angle is angle 2. What does angle 2 go with for an alternate exterior angle pair?
8.
Angle 8. Exterior, outside the two lines. Alternate, opposite sides of my transversal. Now my very last one, consecutive interior. We typically don't talk about consecutive exterior that often. They have cool properties, but you don't really need it when you have the other 4. So we're just going to do consecutive interior. One of my interior angles is angle 4. I need another interior angle, but on the same side of the transversal. What do we think? Angle 5, exactly. Angle 5. Do we see how they're both in between the two lines and on the same side of the transversal? They're on the left. Angle 3 is my other interior angle. What angle is also an interior angle, but on the same side of the transversal as angle 3?
7.
Not 7. 7's on the outside. Close. 6 is also on the inside and on the same side of my transversal. Perfect. Angle 6. Questions on those? Identifying those angle relationships. Okay, we're going to do a few more, and then you'll have homework time. Describe the relationship between the angles. So this one gives you two angles. You have to say what relationship they have. Let's look at angle 1 and angle 2. First, inside or outside? Inside. So something interior. Because inside. Okay? Opposite sides of the transversal or the same side? Yeah, opposite sides. One's on the right, two's on the left. So since they're on opposite sides, we use the word alternate. So this is an alternate interior angle pair. Next one. Inside or outside?
Outside.
Outside, so exterior. Alternate, opposite sides, or consecutive, same side? Alternate. We have to hop across our transversal to go from one angle to the other. So alternate, exterior. This one's a little trickier. What's our transversal here? Is it line 1, line 2, or line 3? I agree, it's line 3. We kind of have to turn it a little bit. It's line 3 because here's our two lines and here's the one line that goes through both. Okay, so you're looking for the line that intersects both lines, and that's your transversal. So angle 5 and 6, inside or outside?
Inside.
Inside, so interior. Same side of the blue line or opposite sides? Same side. They're both on the top. So consecutive. Or if you write same side, you'll get full credit as well. Same side interior, consecutive interior, they're the same. Questions on those three? What's up? Yeah, I got you. I got a watch on. I know. Thank you, Bill. Yeah, go ahead. Okay. For number 3, I want you to do these on your own or with the people around you. Check with me when you're done, and then you will have homework time, okay? So do those, check with me, and then start your big ideas. These two? 14, 12, yes. 1 and 13. 113 is tricky. It's actually just it's the ones that we did in like the warm-up or at the beginning. It's actually none of the ones that are formed with that transversal. Does that make sense? Did you hear me for that part?
Yeah. What would you say?
They're vertical. I think. They're across from each other in your X shape.
12 and 14 since they're much
You're right. They're not both outside or inside, so it's kind of weird. There is one option where they don't have to be the same, but they have to be in the same spot. What spot is 14 in? Let me turn like this. You see it? There, yeah. So they're in the same spot. So yeah, you got it. All right. For time's sake, let's just run through these together. Angle 9 is right here. Angle 15 is right here. Kind of have to tilt your head a little bit because your transversal is this piece. Okay, it's the line that intersects both of your other lines. So here's your transversal. 9 and 15 would be inside those two lines, but on the opposite side of the transversal. So alternate interior. Inside these two lines, but opposite sides of your transversal. 1 and 13 was meant to trick you. Those are none of the angles that we learned today. They're from Unit 1. We talked about them way up here, and I said they're not going away. 1 and 3 right here were called vertical angles. Those are the ones across from each other in that X shape. So 1 and 13 here are vertical angles. (14 and 12). I would first ask inside or outside, and this one's weird because 14's on the inside and 12's on the outside. But then you kind of ask yourself, are they in the same spot? 14 would be, depends on how you look at it, but bottom left essentially. 12 is bottom left, so they're in the same spot. We would call them corresponding angles. And for that one, your transversal was this line right here. And then the very last one, angle 2 and angle 10. Your transversal is this green line. Outside your two yellow lines, so it has to be exterior. And opposite sides of the transversal, so alternate. Exterior. Questions about anything from today?